But just now we have shown that the slender body motions, the kinematic property not be described completely because the angular acceleration is unknown. We will use the force-mass acceleration relationship to compute the angular accelerations. If we look at the equation, we find that the force-mass acceleration relationship consists of a system of forces. So we have to identify these forces. So we have to draw the free body diagram. Just identify the location of interest, the unknown force with this component. Let's say we have A, we have a component of a force A at X and Y direction. Similarly with the weight, the component of X in Y direction. And B, BY and BX direction. B is the actual force acting on the slender body, point B, point G, and the origin is coincide with point A. 30-pound force which is acting in that direction, and when it's moved there is a friction that opposes the motion, so I just put here FA. And at this location also we just assume there is a force A. And then we have weight, and this weight makes angle of 270 degrees with the horizontals. Why identify the angle here? Because I want to convert it into X and Y component, and then using this conversion matrix. At B, we have the force that opposes the motion in that direction, unknown force B. In the question, it says that the roller N and A and B is moving inside a smooth guide. So we assume that the friction at A is equal to 0, and the friction force is approximately 0. The equivalent kinetic diagram for this geometry, the slender body will have a component in X and Y directions, and we expect also there will be some rotational motion, and acceleration here is also unknown. Just now we show you the force that we break it into its component, X and BY, with mass center X and WY. Represented in the figures, the body will form the system of force. We want to write them in the mathematical expression. Force vector A, I'm write it in the matrix form, AX and AY, and I'm going to put here point A, BX and BY at point B, and for the weight we're going to use the conversion matrix. Cos 270 sine 270 minus sine 270 cos 270, and this one will be equal to W0. W is 60 pound, cos 270, and where I get the angle, the weight vector is making 270 degree from the horizontal. Cos 270 is 0, sine 270 is minus 1, and this one is 1. Here is 0. So when we do the matrix multiplication, what we find that this one is equal to 0 minus 60. Here, I can expand the AX, the 30 pound force, and then minus the friction force that opposes the motion, FA. AY will be A. Here, FA is assumed 0 because of the smooth guide, so this one will be removed. At point B, we have defined as B. By is minus FB. And here we assume that the vertical guide is smooth. Friction force will be approximately at 0. So I'm going to write it back. Will be 30A, and this one will be 0. Alright, so we want to write them in the proper equation. That summation of force in X and summation of force in Y in metric form. A, and this one at point A, plus the weight component 0 minus 60 at mass center, plus the B 0, this one will be equal to mx and my dot at G. The right hand terms can be written based on the angular acceleration. M3 minus 3 Mn minus M, evaluate mass center.